colleagues, let me share my screen. Let me try to do it. Okay.
I think it will be successful.
I thought it was not my turn yet, however. Can you see my screen?
Yeah, we can see.
Okay. Uh, uh, However, I am switching the slides. Does it work? Okay. Let's try. Perhaps it's better to share entire screen. Once more again, tell me please if you can see the screen. Perfect.
It's good.
Finally, yeah, thank you so much. Hello, dear colleagues. My name is Olga Pavlova. Our team from Khmelnytsky National University works on early fire detection using computer vision. Let me present our current research work named Fire and Smoke Recognition Method for Early Detection of Landfill Fires. In May 2016, there was a fire at the Khrupovichy landfill near Lviv. 4 people died due to a debris slide. The work of the landfill was stopped and the garbage from Lviv started to be taken to other landfills in the regions and Ukraine. Unfortunately, such incidents are not rare in Ukraine because of the accumulation of the methane due to the decomposition of waste and due to the increase in the average annual air temperature, global warming. Fires often occur in landfills. They are dangerous because they spread quickly, occupying a large area, emit harmful and poisonous substances into the air and are difficult to extinguish. This slide shows extinguishing the fire at the landfill near Rivne. The fire covered an area more than 300 square meters. To eliminate the fire, 6 rescue tanks, a tactical robot, 3 local fire brigades, and equipment serving the landfill were involved. Our team that works on this project is from Khmelnytsky city. This slide presents the Khmelnytsky Municipal Solid Waste Landfill, which is located on the territory of the city. These photos were taken by us as a part of the tour organized by the Khmelnytsky Smart Environment Office. We visited the municipal landfill. Admittedly, its scale is huge. Therefore, the relevance of our research lies in the development of the mathematical model of image recognition for the method of landfill fires prevention using computer vision, and in the event of their occurrence, to detect them as early as possible in order to reduce the spread of harmful substances into the environment. In our previous works, we proposed the structure of the information system for early fire detection that consisted of 3 subsystems. The first one is surveillance subsystem that includes the CCTV cameras. The second is image recognition subsystem that had the pre-trained neural network model inside, and the alarm signals subsystem that provided the conclusion about the fire or the absence of fire at the landfill. The architecture of the proposed system is shown on this slide. The basis of the information system for detecting the fires at the landfill proposed in this work. It is based on the method of fire and smoke detection using the technology of image recognition on video frames taken from the external surveillance cameras and the cameras to ensure the safety at the solid waste landfills. The algorithm underlying the method is based on the recognition of fire-like pixels in the RGB model with chromatic and dynamic analysis. And the method consists of the following steps, such as selection of fragment from the video for recognition, segmentation of moving areas using image differentiation, separation of fire-like and smoke-like pixels, checking the authenticity of smoke or fire by checking dynamic features, and check if smoke and fire are spreading by checking adjacent video frames. A fragment of smoke and fire recognition algorithm is presented on this slide. To implement the recognition subsystem, its architecture was designed based on the convolutional neural network. It is presented on this slide. To adapt the CNN-based image recognition model to the method described above, we need to incorporate steps for video processing, segmentation, feature extraction, and dynamic feature analysis. Here is how each step can be integrated. The first step of the method is selection of the fragment from the target video for recognition. This step involves selecting a sequence of frames from the video that can be represented by the formula where each frame has the three-dimensional array of parameters of H, W, and C, and V can be represented as a set of its frame denoted by the formula 1. The second step is the segmentation of moving areas using image differentiation. For each frame, t and the previous t minus 1, we calculate the absolute difference between pixel values by the formula 2, and to identify which pixels correspond to moving areas, we apply a threshold tau. The segmentation mask, as with the index tau at the time, is given by the formula 3. The third step is the separation of fire-like and smoke-like pixels, where we use the fire criteria function. And in every iteration, we check if the pixel value with the index t, i's, and j's meet the condition for being classified as fire-like by the formula 4. And the fire criteria is denoted by the formula 4, and smoke criteria is denoted by the formula 5. The fourth step is checking the authenticity of smoke or fire by checking dynamic features. To verify if fire-like pixels are truly indicative of fire, we analyze their behavior over a sequence of frame, and we define is dynamic fire function to assess if a pixel at position I and J shows a dynamic behavior consistent with fire. We denote it by the equation 6, and the same for the smoke that we denote with the equation 7. And the fifth step of the method is checking if the smoke and fire are spreading by checking adjacent video frames. Let S, fire with the index T, represent the total area covered with fire-like pixels in frame T that is calculated by the formulas 8 and 9, and the same for the smoke with the S with index smoke T, and it is calculated by the formulas 10 and 11. To confirm the efficiency of the method and the algorithm, we used approaches from our previous works, namely for conducting experiments, the YOLO V8 model was taken, which was trained on a previously collected and classified dataset, which consists of 3,915 images with the following distribution: 3,642 training images, 255 validation images, and 18 test images with classes smoke, fire, other, and null. The example of the image for training that includes 3 classes is presented on this slide. The results of model testing were obtained by using a real image of landfill fire, also presented in the slide. The percentage of fire recognition is 47%. The percentage of smoke recognition are 22 and 58%, which indicates the need to improve the model or increase its training cycles to obtain more accurate results. This will be the goal of our further research and experiments. To conclude, in the course of the study, the impact of the harmfulness of fire at landfills on the environment is considered. A method and algorithm and a mathematical model for recognition fire and smoke pixels for detecting fire at landfills with the help of outdoor surveillance cameras are proposed. An experiment was conducted on the training of a neural network based on YOLO V8 model. When testing the results of the model training, the results of fire recognition were by 47% and the smoke by 58% and 22% on the target image were obtained. Further efforts will be aimed at improving the method and the model to improve the accuracy of the smoke and fire detection. Thank you so much for your attention.
Who has questions? It should be maybe a good time for that. Okay. I have questions about your input data. You talked a lot about data, fires, smokes, and so on. Which data did you use? How you obtained your data set? Is it aerial, just photos, satellite data, and so on?
Thank you so much for the question. Actually, the data set was the ready-made. It was found on the RoboFlow website, and it was previously prepared for this operation for the training. And here on this slide, we have the example of the image with the classification. It is the image from the data set for the model training. And as I previously mentioned, that the indicators or the markers or the classification was in 4 classes. It was fire, smoke, other, and null. On this image, we can see the three classes. They are smoke, fire, and other. And as we can see, the person was recognized as other.
What is about field slides? Yeah. The same situation. Which images did you use for that? Just photos of the.
Yes, it was just photos for training and photos for validation. And if you mean this image on the right, on this slide, it means that this image was just taken from the internet. It was the example of the real fire on the landfill, because we couldn't get the data set by ourselves, because fortunately, it's better to say, we don't have currently the fires on the landfill to collect the data set by ourselves. So we just used the image from the internet by Google that represented the fire, and we validated our neural network, our model on this real image. And as we can see, that the quality of the image is not pretty good. However, it works.
Okay, Thank you. Maybe raise new questions. Somebody else wants to ask something. Okay, well, thank you very much. There is no questions. It's clear. You should continue your work, of course, and present new results and new conferences. It's yeah, it's related to all of us, I think, because your presentation was the last in our second stage, not stage, but second part of our sessions. So continue our scientific results, and we will present our results on upcoming DESSERT conference and other conferences. So don't stop. Thank you to all of us. Yeah.